First question we have, what is a molecular formula for butane? Okay. For butane, C4H10. So funny enough, actually, as the answer also states, the answer is actually given to you right here. This is the molecular formula for butane. Now, to be able to get there, though, that's the part you have to understand. When you're naming hydrocarbons, okay, you have to recognize how they, I guess, each prefix indicates how many carbons you have, okay? So we're going to just go through a quick sheet. We have, for the hydrocarbons, it's meth, which translates to 1, eth, which translates to 2, pro, which translates to 3, or prop, bute, which translates to 4, 5, pent, which translates to 5, hex, which translates to 6, hept, which translates to 7, oct, which translates to 8, non, which translates to 9, and dec, which translates to 10. So these are all you have in terms of the prefix. Now, in regards to the suffix, okay, this is where it gets a little bit trickier, and when they're just asking for molecular formula, they just want you to be able to, do the correct math. So when it ends with an ane, okay, the amount of hydrogens you have is whatever number you see like here in terms of like what you've identified as the amount of carbons, and you have to do 2n plus 2 that amount. So if we wrote down our formula of CnH, it will be H2n plus 2 when it comes to things that end with A and E as its suffix. So with that being said, as you can see when we plug it in, butane, based on this chart here, is 4. So 4 carbons. So then the amount of hydrogens would be 2 times 4, which is 8, plus 2, which is 10. And that is how they got this. Now in this question they asked if they were asking for the empirical formula. The empirical formula, that one's a little bit trickier. The concept there is that if they said, okay, this formula by moles is composed of this percentage of carbon and this percentage of hydrogen, that would be how you would use those values to be able to find the empirical formula, because the difference between empirical and the actual molecular formula is the empirical formula does not factor what the actual molar mass is. It just gives you your lowest multiple constituents of it. So you see how butane is C4H10? The empirical formula would be that, I guess the lowest common, taking out the greatest common multiple in 4 and 10. In this case, it will be 2. So that's how they ended up with C2H5. Because if you're doing like the whole percentages, the percentages won't tell you like how many of each carbons you actually have. It just tells you how many carbons you have based on how many hydrogens you have, and they usually work with whole numbers. That's why this is our lowest, I guess, ratio, if that makes more sense. So we actually have, for every 2 carbons, there's 5 hydrogens. We don't know how many carbons they are. We just know that for every 2 carbons, there's 5 hydrogens, okay? So exactly, the simplest ratio formula. But that would be for like the empirical formula. Here, it was asking for a molecular formula. And although it did give us the answer, the important thing is to memorize this chart here, okay? And this equation here to also find out how many hydrogens you have. Alright, so let's now move on to question 9. This is correct. They weren't wrong in saying that you got the answer. So, number